In this lesson, we will discuss solving quadratic inequalities. So all of these notes are already filled in. I'm not going to read through everything. I'll kind of refer to this as I work the problems. But just in the beginning, remember that the symbol that points to the right is the greater than symbol. I remember this sometimes because right has an R in it, and so does greater than. And the symbol that points to the left is less than. And again, left has an L in it, and so does less than. So there are two ways that you can solve a quadratic inequality. I'm going to let you choose which method you use. So I won't, on a quiz or a test, I won't give you a specific method to use. You can choose whichever method makes the most sense to you. One method is algebraic, where you're actually testing values, and the other method is the graphing method, where you make a really rough sketch of the parabola and then determine what part is above or below the x-axis. Regardless of whether you're using the algebraic method or the graphing method, the first two steps are always the same. So the first thing you want to do is get that quadratic inequality in standard form and set it equal to 0. And then you want to use one of the methods we've learned to solve the equation. So we're either going to use factoring, or the quadratic formula, or the square root formula. And the reason why we wanted to get it equal to 0 and solve the equation is because these are called the critical values, and that is where the parabola will go from either being greater than or less than. I'll give you an example. So let's go ahead and work through example 1. So in example 1, we have the inequality x squared minus x minus 20 is greater than 0. So our preliminary work is done for us, whereas this is in standard form and we have 0 on the other side. So now what we want to do is look at the equation x squared minus x minus 20 equals 0, and we want to solve this equation. Now this one is factorable. I know that because I'm looking for two numbers that will multiply to give me negative 20 and add to give me negative 1. So if I think about that, I've got 1 and 20. Well, that's not going to give you 1. I've got 2 and 10, but 10 minus 2 is 8. 4 and 5, aha, because 5 minus 4 is 1. So, because the coefficient of x squared is 1, I can go ahead and set my parentheses up. I know I'm going to have x times x. I know one is going to be positive and one is going to be negative because my last term is negative. And then the greater factor, 5, is going to be negative because my middle term is negative. So now if I set each one of these equal to 0, I've got x equals negative 4, or if I add 5 to both sides, I get x equals 5. So if I'm looking at method 1, what I'm going to do next is I'm going to put these two numbers that I just found on a number line. And what that does is it creates 3 different intervals on the number line. So what I'm looking for are which of the intervals, when I pick a number and plug it in the original inequality, will make that inequality, in this case, greater than 0. And if it's greater than 0, it's going to be positive. So let's look at our intervals. So I'm looking in this first interval, and I'm trying to find a value in this first interval here. So a number in that interval might be x equals -5. So now I'm going to take my algebraic equation. So I have x plus 4, times x minus 5. And if you plug -5 in here, -5 plus 4 is -1. If I plug -5 in here, -5 minus 5 is -10. And -1 times -10 is positive. So since it gave me a positive answer, it's actually positive 10, but really the most important thing is that it's positive. And I'm looking for what values of x will give me a value that's greater than 0. Well, positive 10 is greater than 0. So this interval worked. Now in interval 2, I need a number that's between -4 and 5. And if 0 is in that interval, I usually choose 0 as my test number because that's easy to test with. So I have 0 plus 4 times 0 minus 5. And in all honesty, I'm really just worried about the sign here. So 0 plus 4 is a positive number. 0 minus 5 is a negative number. And a positive times a negative is going to give me a negative number. Remember, I'm looking for values of x that will make this expression greater than 0, and a negative number is not, so interval 2 does not work. So finally, with interval 3, I'm going to choose x equals 6. So 6 plus 4 times 6 minus 5, well, that's a positive times another positive, which is positive. It's actually positive 10 again, and 10 is greater than 0, so it works. So using the algebraic method, I have found that this interval, which is from -infinity up to -4, and this interval, which is from 5 to infinity, are where the values of x will make that expression positive or greater than 0. Now I also have to ask myself, should I put parentheses here or brackets here? Since there's no equals to on the inequality, I'm not looking for the numbers that make it equal to 0, just the numbers that are greater than 0. And -4 and 5 are the numbers that made it equal to 0. So to not include those, I put parentheses there instead of brackets. Now I'm going to go ahead and also show you the graphing way to solve this. Which was method 2. So if you remember, the directions said to make a rough sketch of the graph. So I'm just going to put my coordinate plane here. And -4 and 5 are on the graph of the parabola. Remember that when you find the values that make x equal to 0, then not only are these the solutions, but they're also the x-intercepts. And I just abbreviated solutions, SOLNS. So I know the graph of this parabola is going to cross the x-axis at -4 and at 5. I also know that since A is equal to +1, it's going to open up. And so since I have my x-intercepts, -4, 0, and 5, 0. And I know the graph opens up, I can draw a very rough sketch of the graph. Now here's the point, here's the logic behind the graphing method. I'm looking for where the graph is is greater than 0. So the values that are greater than 0 are going to be above the x-axis. So if it's greater than 0, you're looking for the pieces of the graph that are above the x-axis. So that's what I meant here. If the inequality is greater than or greater than or equal to, you're looking for where it is above the x-axis. So now if I describe the values of x for which the parabola is above the x-axis, again you see the value of x here is -4, and it's going to be over here. So that's from -infinity up to -4, union, then this side will be from 5 to infinity. So now remember, you use parentheses there because we don't want to know where it's equal to 0. We just want to know where it's greater than 0. And so you reach the same solution regardless of which method you use. Now I'm going to go ahead and look at example 2, because if you notice, it's the same inequality. The only difference is that in this case, it's less than or equal to 0. So if I look back up here, these values in the middle gave me the negative values. So in this case, if it's less than 0, I'm looking for the values that make it the expression negative. And that was from -4 to 5. And because I have the equals to, I would put that in brackets. You reach the same conclusion if you look at the graph, because if it's less than 0, you are looking for where the graph is below the x-axis, and that is between -4 and 5. So whether you're using the algebraic method or the graphing method, you are going to get the same answer for example 2.